So today we're going to jump back a little bit and talk about derivatives. If we remember what a derivative is, it's basically the slope of a tangent to a curve at a single point. So if my curve is a parabola and I have a point here and a line tangent, the derivative is just the slope of that tangent line at that specific point. And you'll remember what we did to find the equation of that slope. We took and did a slope calculation. Basically took f of x plus h minus f of x over h and then took the limit as h went to 0. So let's go ahead and refresh ourselves with the problem that we did a few weeks ago. We want to find the derivative of this function in terms of an equation. So we'll take f of x plus h, define what that is. That's 2 times x plus h squared plus x plus h, and then we know f of x is simply the original function. So let's plug that in now. F of x plus h, 2 times x plus h quantity squared plus x plus h minus f of x, which is 2x squared plus x, all over h, and we're going to take the limit as h goes to 0. This is going to require some simplification. I have 2 times x squared plus 2xh plus h squared plus x plus h minus 2x squared minus x over h as h goes to 0. Clean it up even more. There's 2x squared minus 2x squared, which goes away. 4xh. I have no xh terms, so this is 4xh. 2h squared, don't have any h squared terms. Plus x minus x goes away, plus h. All over h, taking the limit as h goes to 0. So now I see I can take and factor. So let's go ahead and do that. I can pull an h out of the numerator and have h times 4x plus 2h plus 1 over h, taking the limit as h goes to 0. The h reduces, so I have the limit as h goes to 0 of 4x plus 2h plus 1, which is equal to, this 2h is going to go 0, end up with 4x plus 1. So if I go back to my original and say, what was, if f of x is 2x squared plus x, what's the derivative of that, or the equation of the slope? That's just 4x plus 1. Kind of an involved process. Now, we're going to make that process a little simpler, but before we do that, we'll go ahead and talk about some specific terms here. If I have a line of y equals c, in other words, a horizontal line, because c is a constant. So I have a horizontal line and I want to know the slope of that. Pretty simple. We found that out freshman year. Slope is equal to 0. If I have any line in the form y equals mx plus b, we know that our slope of any linear function is just the m. The slope is the slope. So therefore we can state that the derivative of any constant, here's my constant, is going to be 0, and the derivative of any line is just the slope m, which we knew. Now, moving forward, let's take a look at what we just did. We found the slope of this function to be 4x plus 1. Now, if I wanted to find the slope of this function, I could simply do my f of x plus h minus f of x over h and take the limit of that. But I've already done that, and I'm going to give you a quick derivative, which is right here. Now, let's take it a step further and say, what if I wanted to find this derivative? This would be a total disaster in that I'd have to go f of x plus h, and in this problem, if I want f of x plus h, I'd have to take that to the 5th power. Before I just multiplied out that binomial, in this case I'd have to multiply out a 5th degree polynomial. Total pain, and then here I'd have to do a 3rd degree, and then this wouldn't be too bad, but these first two, almost impossible. So once again, I've kind of calculated the derivative for you and given it to you right here. Now I'd like you to look at a pattern that's developed between each one of these, both the function and its derivative, the function and its derivative, the function and its derivative. And just take a look and see if you can see a pattern as to how that derivative is calculated from the function. I'm going to spoil the fun for you. If you take a look at each term and its term's derivative, you can see that the power has been multiplied by the coefficient out in front, and then the power has been reduced by 1. Even on the x, that still happened. The power is multiplied by the coefficient out in front, which is 1, and then the power of x has been reduced by 1, so I get x to the 0, which is 1. Notice here, same concept, 2 times 5 is 10, minus 1 is 1. Alright. 3 times 1 is 3, minus 1 is 0, and x to the 0 is basically 1. And then here I have x to the 0. 0 times 6 is 0. Another way to look at it is the derivative of a constant is 0. Likewise on this last one, 5 times 4 is 20. Subtract 1 from the power. 6 times 3 is negative 18. Subtract 1 from the power, etc., etc., etc. The derivative of a constant is 0, so that goes away. So in short, we can take a look and say, given any expression that can be written as the sum or difference of terms in this following form, if f of x is equal to some constant times x raised to the n function, then for every term like this, its derivative is found by taking the power multiplied by the constant and then taking 1 away from the exponent for all terms in the expression. So let's find a bunch of derivatives now. If I want to find the derivative of this function, I can say f prime. Once again, this is the equation of the slope of the tangent line. I can say 7 times 12 is 84. Subtract 1 from the power. I can say 2 times 4 is negative 8. Subtract 1 from the power. I can say 1 times 2 is 2. Subtract 1 from the power. I get x to the 0, which is 1. And then the derivative of a constant is 0. So there's my derivative. Much quicker, much easier. However, some of these will not be so pretty. In other words, I need to put this function in terms of cx to the n form. So notice I don't have a power here clearly. I can rewrite that though as x to the 2/3 plus 4x. So now I have an equation written as the sum or difference of terms in the cx to the n form. So to find the derivative, once again, I multiply the power by the constant term in front, so that's 2/3. Then I take 1 from the power. This has a power of 1. Multiply that by 4. Take 1 from the power, that's x to the 0, 4. So here's my derivative. Not bad as long as you can write each term in cx to the n form. Taking another one. Notice this isn't in that form yet, so I'll put it in that form. That's 4x to the negative 5 plus 3x squared plus 7. Therefore, the derivative, multiply, get negative 20. Subtract 1 from the power, and I get negative 6. Plus 6x, derivative of a constant is 0. Done. Now what we're going to do is write the equation of the tangent to the function. So this is some cubic. I don't know what it looks like, but let's say it looks something like this. And we want to find the equation of the tangent to this curve at the point 113. Let's call that, I don't know, let's say it's right here. I want to write the equation of this line. Well, in order to write the equation of this line, I need the slope of this line at this point. And this point is the point 113. So let's find the derivative first. The derivative is 3x squared plus 5. And what that is that's the equation of slope. So now I need to find slope at x equals 1. So therefore, I'm looking for f prime of 1, which is 3 times 1 squared plus 5, or 8. And that's equal to the slope. Therefore, I have y equals 8x plus b, and I want to find the equation of this line at the point 113. So I can plug in. Say 13 equals 8 times 1 plus b. b is equal to 5. So y equals 8x plus 5. So hopefully we made life a little bit easier today, and you can see this pattern that's developed. Write your summary out, and we'll talk about it more tomorrow.